just to give you an idea of where we are in this example, we analyzed the paralyzed veterans using decision trees. We basically in the last videos considered two type of models: a deep tree, where we basically set the parameters to be a max depth of 6, minimum bucket of 25, and a CP of 0.001. Remember that this is the parameter that would allow us to get the deepest trees. Um, so having done that, we obtained the following tree, which some of the cases here are not even discernible. I don't expect you to look at those, but um, we found that the area under the curve for the validation was 0.67. The area under the curve that's for the training, and then for the validation that's 0.5696. So the model appears to be overfitting. Um, we also took a look at the values, the count of ones in the top 100, sort of a lift kind of approach, where we basically ordered the propensities from highest to lowest, and then basically determine how many ones, that is, how many people donated in that tiny sample of 100. So we found that in the training, 53, well, in the validation, 53 um, of the observations had customers who donated out of the 100. That is a little higher than what I actually is expected, which is 50. Um, so the lift is just 1.03 in that case. In the top 200, we found 121. Remember that we expect 50% of the observations to be donors, because the data set originally is 50-50, but we had 121, and that is a lift of 117.9. We also did a pruned tree, which we used the pruning method based on the a split that actually reduces cross validation error. And basically, this is using the prune function. We selected the CP such that uh, we got the lowest cross validation error. Okay, so in that tree, we obtained this where the gift count the last 36 months was the most important variable. We also uh, the last gift amount, and also the demographic cluster were important variables. In terms of AUC, we got 59.42 on the training and 57.49 on the validation. 62 out of the top 100 customers were donors, so that gives us a lift of 1.20, which is a lot better than what we got before. And then 120 out of the 200 were donors, which is for 1.69 lift on the top 200 observations. Now, if we combine all of this into a table, then what we get is that Model 5, in terms of the AUC validation, Model 5 is actually doing better than Model 4, which is the tree that is a deep tree. We also get a better lift on the top 100 customers. We don't do as well in the top 200, but we are going to go with the model number 5 to be the top model for the decision trees. So now what we're going to do in this set of videos is to do ensemble trees, ensembles of trees, and we'll take a look at bagging at random forest and at boosting.